Good morning. Welcome to the Woodrow Wilson Center. My name is Jennifer Turner, and I direct the China Environment Forum here. I've been here for 23 years. A lot of my work is focused on US-China climate relations, biodiversity, food, but water's been at the heart of what we do here. I did my dissertation on water policy management in China, and so I'm always particularly excited when we have meetings that are dealing with water, and today we do. Today's meeting is titled "The Blue Planet Turns Green: Algae Fouls Water as the World Struggles to Grow More Food in a Changing Climate." This meeting is co-sponsored, as you see, by the Wilson Center, my project, the Environmental Change and Security Program, and Circle of Blue. So, as the world struggles to feed itself using more land and more water, nutrient runoff from intensified agricultural production has triggered systemic ecological threats. Toxic algae blooms in rivers, lakes, deltas are erupting annually on major water bodies around the world. Today, we're going to talk a little bit more about Lake Erie and China's Yangtze Delta. But remember, the problem is global. These algae blooms are fouling public drinking water systems, affecting the health of millions of people, and not surprisingly, warmer temperatures are exacerbating these blooms. Today, though, we're not just gloom and doom about the problem. Our speakers, they will discuss the causes and the results, but also talk about the solutions to this escalating challenge in the US and China. We're going to kick off today with my buddy Keith Schneider. He's a senior editor and chief correspondent at Circle of Blue. He's going to share insights from a 6-part series into the drivers of Lake Erie's toxic algae blooms. I got to know Keith back in 2010 when my project and Circle of Blue did a project called Choke Point China, looking at the water, energy, food confrontations there. And yeah, Keith, we have fond memories that, I mean, he did a lot of the research with his team. Keith and I got lots of TED Talks around China. And our research and reporting actually led to a lot of new projects starting at universities and NGOs and became part of the US-China 2014 climate agreement. More on that later if you're interested. So after Keith talks, we've got Laura Johnson, a new friend. She's the director of the National Center for Water Quality Research at Heidelberg University in Ohio. She's going to go a little bit even deeper than Keith into the causes of the blooms and highlight innovative solutions that scientists have been developing and that are being deployed by state governments and NGOs in the Great Lakes region. Her center is a real powerhouse in long-term monitoring of streams and waters. And that's why, so she's speaking from science behind her, ladies and gentlemen. All right, after that, another new friend is Yuxiang Wang. He's a professor in the biology department at Queen's University. It's on the maybe not exactly on the banks, but it's on the banks of the Lake Ontario up in Canada. So my 3 speakers today are all in the Great Lakes basins. So he's going to talk about research that he's been involved with to develop innovative solutions to halt algae blooms in China's Yangtze River Delta. This project's being done together with Tongji and Fudan universities. His personal research specialization is metabolic regulation of animals living in diverse and challenging environments. And I'm guessing algae is one of them, but they might be also part of the solution. Stay tuned. All right, this webinar is part of 2 projects that the China Environment Forum is carrying out right now. One is called Cultivating US and Chinese Climate Leadership in Food and Agriculture. And the other one is the Vulnerable Deltas Initiative. We're doing the first one together with Ohio State University and the second one with the East-West Center. I want to flag the fact that Circle of Blue's Harmful Algae Project was made possible by the Fred A. and Barbara M. Erb Family Foundation and the Joyce Foundation. I did introduce the speakers. You guys have heard of like Wedding Crashers. We've got Carl Ganter. He's kind of like my Zoom crasher today. He's going to be participating in the discussion, and he's the founder and chief of Circle of Blue. All right, so Keith, your slides are up here, and start telling us your story. And oh, for the audience, underneath your Zoom, there is a little chat box. Please put your name and put your questions in. You can only put 1 question in every 10 minutes. So if you got a lot of questions, start now. All right. Thank you very much. Keith, the microphone is yours. You need to unmute yourself, Keith. Sorry.
Let's try that again.
Take two. Boom.
Thank you, Jennifer. It's good to be here. Journalists love to talk about their work in public, and this is a real privilege for me. You should know that our experience with algae blooms occurred here in northern Michigan, where we lived along the shorelines of Lake Michigan. In 2014, there was a really big non-toxic algae bloom on the shores of Sleeping Bear Dunes National Lakeshore. And I'm like, where is this coming from? Why is this coming from? And we, as a team of journalists exploring the world, encountered algae blooms, toxic algae blooms, quite a few places that we were in Australia, in the Murray-Darling Basin, the Darling River, in China, in Kunming, in India on the Ganges and the Yamuna. So the idea, the topic, was firmly in our heads about how to put together an investigative journalism project that could let us really dive into this and figure out the consequences, the causes, and the solutions to harmful algal blooms. And it took us until 2021, 2022, when we hooked up with the Herb Foundation and a tremendous lawyer there, Jamie Konopacki, to put this project together. And so that was the start of it. And the focus of it was Lake Erie. But I wanted to talk about, sort of how this is a global problem, a global systemic problem. There are several databases that track harmful algal blooms. There's one called the Harmful Algal Event Database. There's another one from the Ocean Biodiversity System. There's also the IPCC, which is the group that's been tracking climate change science, all of which show that the numbers of these blooms, dangerous toxic algae blooms, is growing worldwide. The Harmful Algal Event Database counts almost 10,000 events. And what was a 10 to 20 event annually earlier, 20, 30 years ago, has become almost a 250 event harmful algal bloom events globally. So the problem is increasing, and the causes are principally agricultural runoff, and they're being exacerbated by warming waters caused by climate change. There's been where this is manifesting itself globally, principally, is in shellfish toxicity. So there's been a fourfold increase in observation of diuretic shellfish poisoning since 1985. There's been a sevenfold increase in what is called amnesic shellfish poisoning since 1985, and a sixfold increase in the organisms responsible for paralyzing poisoning since that time. And in the U.S., it's not getting any better. We have some iconic waterways that are, principally annually experiencing major harmful algal blooms. And the last one was in San Francisco Bay last September, when much of the bay turned green and toxic. So let me now turn to what we found in Lake Erie. Our reporting in 2022, which was a 8-month project, was focused on Lake Erie, focused on the Maumee River Basin, focused on the Michigan side of the Maumee River Basin, which is in the western Lake Erie Basin. And here's what I found out. First, we spent a lot of money, and Laura, you'll hear from Laura, will tell you about this. We spent a lot of money on science to understand what the causes of this contamination is, what where the contamination is coming from, where the discharges are coming from, what's causing it, phosphorus, soluble phosphorus. And we spent a lot of money in the basin on agricultural practices designed to curb harmful algal blooms. In Michigan, about $50 million a year. In Ohio, a little bit more. Nationally, we spend $5 billion a year on conservation practices that are intended to both cure soil erosion and, as a result, also begin to curb the levels of phosphorus flowing into water that cause the harmful algal blooms. Now, what's interesting about this whole subject is that we, as a nation, cured harmful algal blooms in Lake Erie in the 1970s and 1980s, all the way into the early 1990s. And we did so by passing two measures. One was the binational between Canada and the United States Water Quality Agreement. And the second one was the 1972 Clean Water Act, which put restrictions on how much phosphorus in industries and water treatment systems, how much phosphorus they could put into the release from their discharge pipes, and it worked. And Lake Erie, which had been declared dead in the 1960s, revived. And then in the early 1990s, and I think Laura will tell you this, the blooms began to appear again. And they began to appear all over the country. In 2009, the EPA surveyed 49,000 lakes across the country and found that a third of them were experiencing toxic algae blooms. In 2019, the Centers for Disease Control found that 100 people sickened by toxic algae blooms in that year, and that the rate of sickening from toxic algae blooms around the country had increased. Some of this is going on. And of course, in 2014, the Toledo water system shut down for 3 days after toxic algae bloom had inundated their intakes in the Western Lake Erie Basin. In our state, in Michigan, the number of toxic algae blooms reported to the Michigan Department of Environment, Great Lakes, and Energy has increased sixfold since 2022. Now, why is this happening in this region? Well, we found a number of problems. First, the 1972 Clean Water Act essentially immunized agriculture from regulation of its discharges, of how much nutrients were running into the water. Second, we passed these. We paid for at the USDA conservation initiatives, which were designed in part to stem the flow of nutrients into water. They don't work. They don't work in our state. They don't work in Ohio. They don't work anywhere basically where we're farming heavily farming cropland, and they certainly don't apply to the concentrated animal feeding operations, the big livestock operations. Those operations have nutrient management plans, but we found that essentially they're irrelevant to how this is happening. We looked hard at what was happening for the nutrient that causes the producers of the nutrient discharges. And in our region, quite a lot of it has to do with animal agriculture. The rise of the rise of harmful algal blooms in our region coincides with the very steep increase in livestock production in both states. For instance, the number of dairy cows, and then of course livestock produces manure. Manure is collected in major lagoons and episodically is then spread on farmland as a disposal practice, untreated. The number of dairy cows in Ohio and Michigan increased, from 800,000 to 1.6 million between 1978 and 2017. The number of hogs in both states climbed to 3.7 million, 700,000 more than in 1978. And hogs and dairy cows are bigger and grow faster than they did in the 1970s. It takes 6 months to fatten a piglet to market size. 6 months to add 350 to 500 pounds to a hog now. And each of those hogs produces about 3-4 times as much manure, as much fecal waste as a human being. That manure is being spread on much more land. And the amounts that are being poured on the landscape are incredible. In Michigan, we found that dairy and hog farms spread 4 billion gallons of liquid manure on our ground, and 40 million tons of solid manure on our fields. And those weights are being spread on almost 2 million acres in both states. So there's a lot of fecal manure being spread, and the phosphorus and nitrogen from that manure is running into our ground. Now, what are we willing to do as a society to respond to the harmful algal blooms? And I can tell you, we're not willing to do much more than study it, to determine where the sources of the nutrient discharges are coming from. But in terms of curing this problem, we're not doing much. We're not doing nearly enough. And the reason that is happening is, one, the law, both at the regulatory level in Congress and at the state legislatures, does not give our environmental departments sufficient authority to regulate these discharges. And secondly, we have a really politically influential commercial farm community that is protecting agriculture from regulation, that has erected what I call an edifice of immunity to being able to reach into farms and convince farmers and livestock producers to responsibly manage their waste and to be accountable for what is now the largest contamination waste stream in the country. This is the source, the major source of water pollution in the United States today. Agriculture, both crop farmers and livestock farmers, are treated as a special class of polluters. They're allowed by law and very timid regulatory inertia to spread so much manure and to spread so much fertilizer onto the ground to produce crops. 70% of the nitrogen, up to 70% of the nitrogen used in commercial fertilizer flows into water. That's according to the United States Department of Agriculture and to scientists. Now, for the smaller livestock and poultry farms, they have no control at all, none. And so we have hundreds of smaller livestock agriculture, livestock agriculture producers as well. Here in Michigan as well, there's a huge mismatch in our own statutes. We have one of the most powerful environmental laws called the Michigan Environmental Protection Act, which outlaws pollution, outlaws discharges, outlaws any effort to a paramount public concern is to protect the health and safety of our people and to prevent pollution. But this law is not being followed by our legislature or our regulators. All right, let me try to get to a third cause of this. Every state has what is called formal fertilizer recommendations, and they're made by our land grant universities, by our state agriculture departments, and by the USDA, U.S. Department of Agriculture. And they recommend how much nitrogen and phosphorus to put on farm fields in order to produce ample harvest. In every case, those formal fertilizer recommendations recommend far more fertilizer and nitrogen to be put on fields and phosphorus to be put on fields than is needed to grow bountiful crops. In Michigan, half of our cropland does not need another teaspoonful of phosphorus to grow bountiful crops of corn, for instance, or soybean. But farmers are recommended by these formal fertilizer recommendations to put maybe 140 to 150 pounds of nitrogen and maybe 40 or 50 pounds of phosphorus on their fields in order to grow their crops on land that is so saturated with phosphorus they don't need another teaspoon. And this is happening also in livestock agriculture. In our state, livestock manure spreading is allowed on fields that have soil concentrations already of 150 parts per million phosphorus. And our state allows those livestock growers, livestock producers to spread even more manure on fields without penalty. So we have too much fecal contamination and too much phosphorus and too much nitrogen being flowing into our groundwater, into our surface water. And this is causing the harmful algal blooms. All right, what are the solutions to this? The solution to this is easy, and it's been shown in Lake Erie in the 70s and 80s into the early 90s, is that you have to curb how much nutrients are flowing into water. And as I've described, there is not nearly enough effort at the legal level, at the regulatory level to stem that. And I can tell you that this could get worse or it could get better. There are two paths here. A year ago, 2 years ago, almost 2 years, a year and a half ago, Congress passed the infrastructure law. And last August, Congress passed the Inflation Reduction Act. Both laws contain billions of dollars directed at agriculture to turn our farmers and our farms into energy producers. So more ethanol, which is a corn base. Corn is the most heavily fertilized crop in the country. 9 billion pounds of fertilizer applied in our region to grow corn for ethanol. And the second thing is that both laws are encouraging renewable fuels. Well, renewable fuels in agriculture is manure collecting methane from manure. So that law could encourage larger and more numerous concentrated animal feeding operations, more dairies, more poultry farms, and more hog farms. And biodigesters are going to be installed. So the question is, does this make things worth? Well, Congress, in its infinite wisdom, also passed almost $20 billion on conservation programs, which the United States Department calls climate smart agriculture. And the idea is to help pay, subsidize farmers and livestock producers to do a much better job in how they manage their land, to manage their land in a way that absorbs carbon, prevents nutrient runoff, more carefully spreads manure. It's $20 billion over the next 5 years to do that. And will farmers do that? And the question is, I guess history will tell. So as a journalist, I look at this and I say, how do we as journalists begin to help respond to this, what I call a national scandal? And what we're doing at the Circle of Blue is continue this reporting into the Corn Belt to report on nitrogen, and that project is ongoing. Thank you.
Thanks so much, Keith. Yeah, Carl, you could take down those slides right now. Yeah, no, this is fascinating stuff, and there's 6 reports with even more detail. We'll get more into the Q&A, but Laura, you can toss your slides up, and let me already got 2 questions, which I'll ask when the Q&A starts. But reminding people to submit questions in the little box underneath the web streaming here, and putting your name is great because then I can kind of know who's out there. Laura, the floor is yours.
Wonderful. Thank you. Hi, everyone. Thanks for joining me today. I'm Laura Johnson. I am the director of the National Center for Water Quality Research, like Jennifer said earlier. I just want to point out where we're located. Heidelberg is a very small university up in Northwest Ohio. So exactly the types of locations where Keith was just mentioning, because we are in the Lake Erie watershed. And just to sort of bring home this point with a few slides here, just as Keith was saying, in Lake Erie specifically, algal blooms were prevalent in the 60s and 70s when Lake Erie was the dead lake. This is a picture from 1971, but they largely disappeared around the mid-1980s, pretty closely associated with controls on wastewater treatment plant effluents coming into the lake, so reducing that phosphorus. But then these blooms only turned around and then came back in the early 2000s. This is a aerial photo from 2019 showing essentially a massive algal bloom that's taking over a lot of the Western Basin. And honestly, we're standing here. This is where the Maumee River comes in, but across this area over here is Michigan. And you can see what's cool about the 2000s is that we have additional technologies. So we can now use satellite imagery to be able to assess the bloom size and severity. So you can see in this figure here, it's showing a bloom severity index from 2002 to 2022. And essentially what that bloom severity index is, you can see the example here in 2015, and it takes not only how intense the algae is in a particular spot, but then also how widespread it is. So 2015 being our very worst bloom that we've had on record, you can see it was very intense in places, and it spanned from the United States all the way over to Canada. Luckily, over this whole period of time at Heidelberg, we've been monitoring the largest tributaries that go into Lake Erie. So this is a map that's showing all of the major tributaries into Lake Erie. The size of the arrow is associated with the average load from around 2003 to 2013. And you can see the little H's are all the little places where we monitor. So we have River Raisin, Maumee, Sandusky, and Portage, all the way over to the Cuyahoga. These are the biggest arrows of external tributaries coming in. We also monitor a lot of very small subwatersheds as well. And what we're interested in are sediments and nutrients. I'm going to speak mostly on phosphorus today, but we also monitor for nitrogen as well. And a lot of the focus is going to be on the Maumee River because that is the largest tributary into Lake Erie. It comes into the Western Basin, but it's not just an interconnecting channel. So the Detroit River here, also a very large river, it's bringing all of this upper Great Lakes water into Lake Erie. So it's not necessarily the same type of system. So what have we learned? What do we know? I'm getting to a story here, but first I have to get some background out, right? So what do we know about blooms in Lake Erie? Well, what we've learned over time is that it's a very specific period of time that can really drive bloom severity, and it's this March through July time period. So technically, we're in the loading season for the 2023 bloom already because we're already into March. And what we found is that the March through July either dissolve phosphorus load, so that's this orange bar, or even just flow, because they're very closely correlated, are very closely related to bloom size. So I'm going to walk you through some examples here. This is something that really came about over time, and it became very obvious in 2011 and 2012. So starting at the beginning of this figure here, where in 2011, we had a very big bloom. Back that time, it had been the biggest bloom on record. It was influencing the Cleveland drinking water plants way over here. And we had gone from having a super wet spring. In 2012, then we had a drought throughout the spring. But if you look over the whole year, we actually had a lot of rain in the fall. And 2012 was over the whole year was actually fairly comparable to 2011. So that's when we realized, yep, it's March through July, that spring time period that matters. So we went from a really big bloom to a fairly small bloom. And then we see, as we keep going, that this keeps playing out. 2015 was really big, 2016 was small, big bloom, little bloom. 2017 to 2018, 2019 to 2020. All of these years are really playing out and following this general pattern. We can even see that if we put it into our bloom severity index, which I just introduced to you, where we go from these really high years to really small years. One thing that this tells us, aside from the fact that we can use this to forecast bloom size every year, so, and I think it's June 30th this year, we'll be doing our seasonal forecast up at Stone Lab. On top of that, it tells us that this is really, these loads are really associated with rainfall and precipitation in that year, that there's not this big carryover effect, and it's not probably very much associated with wastewater, which would be coming in at a consistent amount every year.
Hey, Laura, hold on a second.
Yes.
I want to tell the audience I've gotten a couple of questions that they can't see your slides. I'm asking if you can't see Laura's slides, just refresh your screen. Okay, thank you. Go on, Laura. Sorry.
Okay, no problem. Okay, so hopefully your screens are refreshed and you can see slides. If not, I will try and describe this in more detail so that you can follow along otherwise. So I wanted to zoom in on 2019. Now in 2019, what we found was that we got a lot of flow. We had a lot of water, but we didn't have as much phosphorus load. The phosphorus load was somewhat smaller. So our water was like, the amount of flow we had was one of the top 3 that we had seen ever in this March through July time period, going all the way back for the period record for Maumee. So it goes back to like the 30s. For the phosphorus load, it just wasn't, it was moderate, but it wasn't crazy. And because of that, our bloom we ended up finding was moderate. It wasn't the largest bloom we had, but it wasn't small either. It was still a pretty good sized bloom. So what happened in 2019? Well, 2019 was the wettest spring that we've seen at least since 2002. Really, it goes back for, I think, the whole period of record that we've seen for this region, or at least one of the top few spring rain events. This figure is showing cumulative March through July precipitation. So it's basically how rain accumulates over this period of time. And you can see that essentially it accumulated the entire time period, meaning that it was basically raining every day or every other day, it felt like, for that whole springtime. What this did was that we ended up having a record high unplanted agricultural areas in the region. I've got a couple of figures here. One showing just from Twitter, a farmer who usually posts every year a picture of him on the 4th of July with his corn. And you can see in 2018, the corn was over his head, typical what we normally see around 4th of July. In 2018 and 2019, the corn was maybe to his knees. Knee high to 4th of July is not a thing anymore. It should be over your head, reaching the sky by 4th of July sort of thing instead. And this is also evident when we look at the vegetation index, which is something you can pull from satellite imagery, where the amount of green that we see in July and August is about half of what we would see in a typical year like in 2018. So what did this actually do? Well, this is a fairly complicated figure, so just listen to the words if it gets too complicated. Essentially, what we know right now is when it rains a lot, when we have a lot of flow, we have a lot of load. And from 2000 to 2018, if it rained more, we got more load. If it didn't, we had less. And they followed this line pretty closely. In 2019, we fell off of that line a lot. And what this tells us, it was about 30% lower than what we would have expected based on how much flow we got. So we had a much lower phosphorus load that year. Now, on one hand, I found it to be quite surprising. You guys might not think it was so surprising because if it's that wet, nobody could could put out phosphorus fertilizers. No manure application was really happening that whole spring. But we still, and because of that, then we also saw that there was a minor bloom. It wasn't the top highest bloom that we would have expected, it was that moderate sized bloom. So this is great. This is interesting. But what does this really tell us? What can we learn about 2019? We had this lower load than expected. And what it tells us is that a lot of things, so many things. So it tells us, first of all, that the actual application of phosphorus is important. So this is a picture. It's just showing a farm broadcasting applying phosphorus fertilizer. That's typically, it looks like how you would apply anything to your yard. You just broadcast pellets over it, right? Well, that act of just doing the application itself leads to more runoff than what we would expect. Typically, when we think about phosphorus in fields, what we think about is that you apply it, it's fairly sticky. Phosphorus is sticky. Nitrogen is not. You apply nitrogen, it likes to wash off. Phosphorus is sticky. Usually you apply it once in a crop rotation. So once it's applied, it hangs around for a little bit and it starts to sort of saturate your soils. And then once you've applied a whole lot, then that's when you start to see a lot of leaking. And so the general impression is that, well, this is a bank of phosphorus. At some point, you're not going to see runoff. You're just not going to be, you'll have something there for your next year. You'll be good. This says that no, actually, maybe up to 30% of our phosphorus loads is coming from the actual application, not that stored phosphorus pool. But we can flip that around, right? On the flip side, it also says that 70% of our phosphorus loss is coming from what's been applied in the past, and that when we get these really wet years, that we're going to have a certain amount of loss no matter what. And so this is important to keep in mind because it tells us that we might need more time to start to see changes in phosphorus loads. Now, before I take up all of the rest of the webinar, I want to go through a few of the potential solutions here. How do we turn these into solutions? And the first one is exactly what Keith was saying. We could probably apply less phosphorus. This is a figure of Ohio's soil fertility fields. These are, those test fields that are around land grants usually. This one's in Wood County, which is right in the Western Lake Erie Basin, and it's showing corn yield over time under a recommended rate, so applying at one time the recommended rate, or applying twice the amount of the recommended rate. And you can see that no matter how much phosphorus is applied, corn yield is pretty much the same across each three of these rates. Now, that's a really scary thing to do for a farmer if you're trying to have your livelihood based off of growing stuff. So the other option is, at a very minimum, we really need to be subsurface applying fertilizer and manure, getting it off of the surface, because that's where it can interact with rainwater. Even as that phosphorus starts to absorb into the soil, it just absorbs in that top centimeter. So this picture is just showing manure that's being incorporated into the soil, and it's going between rows of corn, as you can see the corn here. The other option is to remove nutrients. We have a field that's a problem. It's losing a lot of phosphorus. You can put a phosphorus trap on the edge of it. A lot of our phosphorus is lost through subsurface drainage tile. And so the best way to do this removal is to have this whole field is being drained, to have that main tile go into a filter that has some sort of phosphorus sorbing material. These are expensive. This is all being engineered mostly by Chad Penn. That's at USDA, ARS, and Purdue. But these are expensive to put in, so we can't feasibly consider putting this at every single field. But if we can identify those problem fields, then this is a great solution. So we don't have to wait the amount of time it could take to watch phosphorus go down very slowly after it's been elevated. And then the final option here is potentially putting in something like wetlands. Wetlands are great because Not only do they filter out nutrients, but they also store water. This is a floodplain wetland on the Sandusky River. The river is flowing up the water, the picture here, and you can see that the whole wetland right here is holding a lot of water from this storm event. And as the storm event goes down, it's going to hold on to that water, and then it's slowly going to infiltrate into the ground instead. Now, the state of Ohio is investing a lot of money in restoring wetlands throughout the whole state. This map shows lots of different locations throughout the state that are showing, basically all the places they're focusing in. There's a lot of focus in the Western Lake Erie Basin. It's unlikely that we would ever be able to put in enough wetlands to totally fix all of our issues here. But when you have low-hanging fruit, this floodplain wetland used to be an ag field, and it used to flood like this every spring. That is a waste of a natural resource, right? So taking these types of places that are marginal lands to be farming in the first place and turning them into something that could filter nutrients is a great option. We are a part of a program that's monitoring the effectiveness of these wetlands, so we can provide management strategies to the state in terms of how to manage these to make sure that they continue to work as effectively as possible. Okay, there's some uncertain solutions here too. I just wanted to bring up, I did not talk about cover crops. Cover crops are crops that you put on your field after your cash crop is done, so that you have cover over the winter. This is great for a lot of reasons. It's great for your soil. It's great for climate smart commodity stuff. It's great for keeping, keeping sediment out of our water. But it's not really helpful for phosphorus at this point. That's sort of the science is a little uncertain about how much it actually helps with phosphorus. So while I'm not saying you shouldn't do cover crops, I'm just saying that that's probably not going to be the thing that's going to fix Lake Erie. The next one is drainage water management, putting essentially a dam at the end of your subsurface tile drainage. So you hold water in the field, probably useful in a lot of situations, better to have more water than not, but it's probably not going to help Lake Erie because usually our fields are so wet in the spring, you don't want to hold back any water. Farmers are going to keep these free flowing so that we get water away, and that's what we need to hold it. Alum addition, so any sort of addition of something that's going to absorb phosphorus to make it so that it can't feed algae is great for small water bodies. Lake Erie is huge. People do not realize how big Lake Erie is. To do the amount of alum that we have to add to fix Lake Erie, it would be billions of dollars, billions of dollars, and it would only fix it for 1 year. Once we get all the phosphorus, the next year it'll cover it all up, and then we'll have another bloom. Algae harvesting. A lot of people want to see all the green and they're like, well, why don't we just take it out of the water? That works for small bodies of water again, but you just cannot make a dent in the amount of algae that you see in a water body the size of Lake Erie. And so because Keith was mentioning some of the H2 Ohio and various practices, I do want to note that H2 Ohio does have an agricultural side of things too, not just wetlands. And of these first four are all of those things that I think are going to be great solutions. It does include cover crops and drainage water management, which could be helpful, a little bit questionable about, maybe might help control water, maybe not in the spring so much though. And it also includes our wetlands, and that should have, yeah, and that's a blue star. So, and with that, this is my contact info, and we can move on to the next people.
Thank you so much, Laura. And just for people, I'm pretty sure they refreshed and could see, this is being recorded so they can go back and see your slides. Just, can you give me just a short, because I want to, because you and Keith kind of both mentioned it. Can you just explain the tile system, why that's super important to understand in this conversation?
Absolutely. Yeah. So this whole region was a swamp, right? So most of the Western Lake Erie area previously had been a swamp. And to be able to live in the area, we needed to, and farm in the area, essentially they installed subsurface drainage pipes. They look like the sort of French drains that you use around your house, that essentially if you put them a meter below the soil surface, it lowers the water table so that the land is arable, so that we can have houses and so that we don't get bitten by as many mosquitoes. So yeah, these tile drains, they're called tiles because they used to be made out of ceramic tile before we had a lot of plastic, and they were installed starting probably in the 1850s. So they've been around for a long time. Yeah.
Okay. All right. So just wanted to make sure, because not everyone knows this about the system. Okay, Yuxiang, we're moving the mic over to you. Could you share your slides, please?
Sure, I'll do that.
Thank you.
Hopefully I can do this right.
You can do this. I have faith. While he's doing that, Laura, how big is the H2 Ohio group?
Is that
For
working?
for the wetland monitoring.
Yeah. It's not
There
up
are
yet.
6 major universities associated with it, and we're growing. I mean, every person is hiring more and more technicians to be able to do the monitoring. There are currently over 120 wetlands that we're supposed to be on top of, and so also we have to focus on some and can't focus on all of them because that's a lot of wetlands.
Yeah. So Yuxiang, so
Is it working?
no, it's not on. Are you on the computer that you shared it on before?
Okay, I better do this right.
Yes, we can do this.
The screen 2, I guess.
Yeah, we have too many screens. It's amazing. I've got like 2 myself here. I'm reminding the audience as Yuxiang's pulling up his slides that
Is that working?
not yet. So did you go to the bottom on the green square, the share screen
Yeah,
on your Zoom panel?
on my Zoom panel, yes.
Yeah, and you click on the green square that says share,
I got it.
and then you should see your screen, and you should see the little boxes, and you could put your click on your. You could just click the word share.
Is that working?
Nope. You should be clicking it on the computer that you shared it on last time. I know you've got 2 computers there.
Yeah. Okay, share.
There we go.
Is that working?
I can see your screen, not your PowerPoint yet, but yeah, I can see a picture of a beach. So just click on your, yay, we got it.
That
All
working?
right.
Okay, great.
So it's
Thank
all you. Thank you very much.
All right, yeah. So my name is Yuxiang Wang. I'm from Queen's University, and my team here is also in Canada from University of Toronto, and 2 partners in China, Tongji and Fudan University. So for those of you who don't necessarily know much of your northern neighbor here in Canada, we're on the north shore of Lake Ontario, and also Queen's University is actually at the archipelago flowing from Lake Ontario into St. Lawrence River there. And the University of Toronto is actually an upstream and north shore toward the head of Lake Ontario. So moving downstream a little bit from where Keith and the Laura's are, I'm glad to hear all these issues so that save some of my energies here to explain the severe issues we have here. So the title here is Keeping the Genie in the Bottle. And so we know we have a problem. Algal bloom, a cyanobacteria bloom, is one of the consequences of eutrophication in the ecosystem. That problem is compounded with climate change nowadays. So you will hear some of my well, I'll explain my solutions, our solutions here. One of the issues are when there is a eutrophication issue going on, cyanobacteria blooming is happening. And we hear from both Keith and Laura saying, well, it's really hard to curb eutrophication, that alone with algal bloom going on. So they're causing a lot of secondary issues here. So in last 2 decades or so, we've been working with the colleagues both in China and here in Canada, try to find a solution. So we like to call ourselves innovative solution to prevent algal bloom from happening. While there is a eutrophication still going on, we're still making effort to curb eutrophication. So we already know there's a rise of cyanobacteria blooming all over the world. So as both Laura and Keith were pointing out, so my data goes to 2015, but the rising of algal blooms are probably getting more severe, not only just in the warm warm climate, and also start happening also in a colder climate in some of the Arctic lakes here, and more so, there's also algal blooms start happening in a not necessarily nutrient-rich water bodies. So Middle-West is talking about all the eutrophications, but with the mutation of some algals, cyanobacteria, in this case, they start happening in the cold water body where there's not much of nutrient going on as well. So that becomes more severe. So while that's all happening, how are we going to deal with it? And when we look at algal bloom, so that usually we think of, okay, nutrient overreaching by human activities, as pointed out, agriculture, aquaculture, and also ground runoff from urbanization, all that sort of thing start happening. And then because we know cyanobacteria is they can better use of a nitrogen and phosphate in the ecosystem. So they are having that competitive advantage in comparison to some of the companion microorganisms or organisms living in the environment. And they achieve the optimal growth in a warmer climate, but that's an early statement. Now we know even in a colder climate, they still have that competitive edge in comparison to other organisms living there, usually keep them in check. And then they also do so-called vertical mixing in terms of intensity and frequency. So they move up and down in the water bodies. Therefore, they become almost like a guerrilla warfare. You can't really find them. They sometimes come, sometimes they go, right? So it's hard to spot them. And then therefore, they create another hurdle for us to manage algal bloom in the water body. And then CO2 become sometimes limiting factor for photosynthesis happening in the cyanobacteria. That's a traditional kind of a view. But nowadays, with the climate change, we have a more atmospheric CO2s in the air, and then that limiting factors start diminishing. So therefore, they again they can sequester carbon for photosynthesis for cyanobacteria at a much ease. So therefore, there's becoming another problem. And then there's also change the precipitation pattern and the intensity of precipitation, the spring or runoff, as Laura was pointing out, is causing a huge problem in the watershed. So we already know they are better in sequestering nitrogen and phosphate. They can also fix nitrogen from air. So some of the cyanobacteria has that ability. So that become another harm, potential harm to our system. Challenges, I say. And then they can tolerate, as Keith was pointing out, salinity. So therefore, it's not just a freshwater ecosystem problem. It's also in the marine or brackish water, we can also have that issues as well. And then high temperature. If you look at the chart here, and I should use my laser pointer, cyanobacteria usually can bloom at a much higher temperature in comparison to, for example, diatoms in here, right? So diatom sort of will flourish in a much lower temperature. Some of the green algae, 20-some degrees. But when they get to higher temperature, cyanobacteria can bloom very easily. But we already know that that's no longer true because we used to work in the subtropical lakes in China and the reservoirs, and that's where they bloom. That's the strings we have in there that shows that pattern. Now we know the issue become a little bit more challenging. And then they have a great diversity in both in shape, form, of course, functions, how they work in the ecosystem. And also they have a gas vesicles allow them to migrate day and night up and down. So become a little bit hard to spot them. And how do we, where do we apply our measures to mitigate them become a little bit more challenging. I'll bring my next question, sort of a strategy up and how we deal with it. Also have a mucilage around their body to protect them from grazing. So therefore they become a little bit more challenging to manage them. And of course they produce toxins that become another problem in our system. So we as a human would really get affected by the toxin part of it. So current strategy responding to CHUPS, like a cyanobacteria harmful algal bloom, that's in short, it prevents the bloom, either minimize the nutrient, as we heard earlier, or sediment removal. So some of the high nutrient sediment can be mechanically removed from the system, or using phosphorus inactivation products like fix them, don't let them mobilize themselves into water column to prevent them from blooming. So that's one strategy. And also to control it by direct reduce of sort of algals in the system, either mechanical, biological, chemical, environment manipulation, as Laura pointed out earlier. So there are some machines going on there can get them. right? To reduce, to remove them after bloom already happened, and also mitigate them. So minimize the impact, even there's a bloom. So you can either do the bloom monitoring, event response, water warning, whatever. So the risk communication to the public, that become another measure. So, but that's just current strategies, how we deal with the algal blooms. And then, are we successful? So when you look at it, so even look at eutrophication and also algal bloom control in the past, look at the publications and the patterns issued in the last 20-some years. It's on the rise. So there's huge scientific research going on, and also a lot of technologies going in there to allow us to understand or deal with the algal bloom in the last 2 decades. But the project invested in dealing with the eutrophication algal blooms also on the rise in the big time. But this data is showing in the Chinese system how much money they put in there, because knowing as a big country with a lot of agriculture, a lot of runoff, a lot of population going on, that's very severe. But that problem is actually becoming worldwide. And then when you look at, is that really just a eutrophication issue? Yes, because look at the eutrophication, compare in the 70s to early 2000 to now, look at oligotrophic to eutrophication. So we see a lot of eutrophication and a mesotrophic environment in our system now. And then with that, we see chubs in the lakes and reservoirs are on the rise. There's no doubt about it. Meaning, even though with a lot of research, a lot of money put in there, we're not successful in curbing algal bloom in our environment. And then this is actually not in China. And instead of showing this is in Canada, just on the backwater on the lake sort of a canal system connecting Ottawa to Kingston, and we call the Rideau Canal, the heritage site. And this is my student actually in the summer doing the sampling on a little canoe there where Canucks, right? So we do canoe things. Yeah. And then, so if there's not successful and the prevention of algal bloom, so it requires, what are the challenges? It requires a lot of in-lake nutrient reduction, which is to a sufficient low level, require long-term effort, sometimes even decades. And then there are very few examples of a sustainable, successful cases. Laura was saying, you do it 1 year, then next year you have to come back to do it again, right? So that's just very costly and not sustainable. And when you look at the control part of it, it's actually ineffective in the long term, and very difficult to implement a very, there's measures of large water body, like we're saying, Lake Erie, Lake Ontario, that's really hard to deal with it. And the negative impacts on the ecosystem is huge. To remove proportion of algae from the system is almost impossible. And the mitigation part, and it's not very suitable for portable water body, meaning if the water is the drinking sources, the toxin is there, you cannot mitigate it. So you have to deal with it in another way. So it's a very little consequence there when there's no alternative source of a portable water. So in Lake Tai and in China, 1 year, they had a huge algal bloom going on. Well, that's happening in all the cities around the lake. They were stopping having drinkable water. So they're using truck, thinking about the city of millions and not having water coming. So that becomes a huge issue as well. And then, so so in the last 2 decades, we learned these things. So we will have to use a sort of a systematic system to prevent algal from blooming before it's happening. So we like to refer as like an Eastern medicine theory. So to prevent disease from happening before it happens. So when we do that, so we have worked on different water bodies, anywhere from reservoirs, lakes, and rivers, and different sizes, anywhere from small pond, like 1 square kilometers, up to 60-some square kilometers, just outside of a city of Shanghai, in the lower reach of a Yangtze River, where you have the highest population, a lot of development. And those 2 universities we work with, Fudan and Tongji, they are in Shanghai. And so with that, we can actually control algal bloom when there's a really very eutrophied water bodies in there. And so many of those water bodies are the drinking water sources for city of Shanghai. So we have been reasonably successful. You say, well, are you bluffing? And actually what happened? So this is the cases. For example, this is one of the reservoirs supply drinking water for city of Shanghai. So this is before our implementation of biotraps or eco-trap, we call it. This is after. And same goes with a different water body. This is before, and this is after. So you say, well, it is working. And of course, another water body. So you can see this is a reservoir, it's not natural, all the concrete banks around there. So it doesn't really provide much of a shoreline and not having wetland in there at all, right? So, so how does it really work? When you think about it, if you try to inhibit the cyanobacteria from blooming, it is really hard. Think about it. Cyanobacteria have been there for billions of years, while the human have only been here for millions of years. If you try to win this battle to get rid of them, that's probably not possible, right? So, but the thing is to have to keep it in check. I call it genie has to be kept in the bottom. And then to prevent, we like to call it a proactive prevention. So prevent and inhibit algal bloom formation at very early stage is the key. And also to curb algal bloom from gaining the competitive edge over other organisms in the ecosystem, literally having a balanced ecosystem or reconnecting the missing links in the ecosystem allow it to work. So to decrease the blooming possibility, allow ecosystem to adjust and to restore itself, that will prevent algal cyanobacteria from blooming. Also afford a valuable time for nutrient removal from the system. We know that will take a longer time to achieve. So that's our so-called bandage kind of approach in here. So how do we do it? So we do early detection and treatment. That's the key. Early warning system is one of the things we do, using UAVs to deal with it and to allow us to find a hot spot and a very time-sensitive manner, and also at a lower cost, and to find the size and the relatively biomass in the water body. That's another key to deal with it. Also, predictive ecosystem management, knowing what is going to happen, allows us to do proactive management of the sort of a water body that will allow us to prevent algal from bloom in the system. And despite there's a huge nutrient loading in some of the water bodies. So using sensor equipped kind of aerial vehicle, and also allow us to nowadays using UAV water sampling, automated deploy our UAVs to different water body to overcome the limitation of human kind of manpower issues, and allow us to get to the multiple spots in a large scale to get water sample, allow us to identify where the hotspots are. Then we can implement a bioremediation to curb algal blooms. And of course, nowadays, we even implement an environment DNA to allow us to find the likelihood of where you have a cyanobacteria in the system without even seeing them through the images. So that's the next level. And with all of this, we'll be able to do the real-time algal distribution at much larger scale, increase the detection limitation and the even very, very low biomass, and also forecasting the extent to pre-bloom algal that allow us to implement our biotraps in the system. So this is by developing the imaging processing capabilities, special spectrum analysis. So we will be able to identify algal. So this is a prey, and after algorithm being applied to the image, we'll be able to see with a much higher detection solutions. So we can actually find a very low biomass or low density of algals in the system. Of course, you have to do this at the right time, because they flow to the surface only at a particular time, this particular set of a condition. So to find that very narrow window is the key. So we are using UAV and doing the machine learning AIs to allow it to get out there to find the hotspot. And with that, so we will be able to do very high detectability, low cost, and a very short delay. So by doing that, the UAVs here, so looking at coverage, spatial coverage, satellites much better than manned vehicle, than ground survey, and looking at a detection time, real time to the month. Then when you think about the satellites somewhere up here, using manned vehicle or UAVs somewhere here, and looking at about ground traveling, that's really, really hard. So what we're trying to do is to develop a capability, technical capability, with the help of Dr. Liu's team at University of Toronto. We're able to use a very small unmanned vehicle to achieve that goal at a real-time, low cost, and a very high resolution. And with this help, and then we can.
Yuxiang, are you about wrapping up here so we can get to the,
I'm done.
Great. Okay.
More slides. So with that, we can control algorithm from happening in the very early stage, a very cost-effective manner. And then some of the cases we have had and success cases that happened in China. And I think we can learn from that experience and hopefully apply some of the technique and technology, other strategy here in the North America, helping our water here as well, right? So that's sort of what we're trying to do. And of course, appropriate evaluation for those of you who are interested in how the biotraps actually work. It's kind of complicated, but I will try. I can explain to you how it works, and they have to take my word to that. So anyway, so the bottom line is to going from traditional method to the innovative method to use a proactive prevention, help us to prevent the algae from blooming in our very precious water body is the key, I guess. So, but with that, and thank you for your attention. I'm happy to answer your question on behalf of our team. So I can't do this without many collaborators and, of course, a very powerful team and very diverse teams, both here in North America and also our colleagues in China as well. Yeah, thank you.
Thanks so much. You could take your slides down and then we could get us all in our big question format here.
Okay.
So just go to the top of your screen where it says, like stop share. Just move your cursor to the top and click stop share, and then we should be good. All right, we've been getting some questions in. One thing, maybe a couple of people, they're asking on both sides, like, what can we do? And but there early on, we had a question from Dr. John Leonard, from an IBM sustainability scientist, and said, I think maybe this is to Laura, but maybe Keith, can you speak about other states, such as here in North Carolina, where we have had frequent river algae blooms in the 1990s, but since then, the algae threat to our waterways and sounds has continued, but with less attention. And that's something too that I was even thinking with China, because about 10 years ago, when I was doing work on Lake Tai, everyone was talking about Lake Tai and algae blooms. And I don't know if people just, they can't stop them and they don't talk about them. But Laura, what can you say? Anything? Do you know anything? I know you're in Ohio, but you or Keith say anything about what's going on in North Carolina?
I don't have anything all that insightful to say about that. I know that in North Carolina, a lot of the challenges are associated with swine operations and inputs from that. If I remember correctly, a lot of their issues are also associated with nitrogen, particularly ammonium concentrations. So that changes things a little bit. I can say that oftentimes when we see blooms in rivers, it's either there's two cases in which you see that happening, because flowing water is usually not a place where you see algal blooms that often, unless we're talking about coastal rivers where flow is slow. Usually there's the one instance is a consistent input, like a wastewater plant. And so if the swine operations are inputting like that, maybe they've got new technologies to hold water back when flow is low. The flip side is if we have sort of weather whiplash instances where we get really wet spring followed by drought. And in the Ohio River, that's happened multiple times. I think 2017 was a really big one, where you get a lot of rain and then it switches to be really dry. So then all of that non-point source runoff kind of stops at the river, and then it can create some real severe blooms then.
Another dimension of this is just disconcerting public tolerance for these kinds of systemic issues. And media attention to it is not nearly what it needs to be, particularly at the national level. So I had a colleague, very prominent Great Lakes journalist, water journalist, tell me after we published our 6 articles that, oh, a lot of that's known. We published a lot of that, which isn't completely true. We've seen that before. That's what he said. And, you know, the last time a journalist said that to me was when I worked at the New York Times on nuclear weapons issue, when I got a similar message from a journalist. And so when journalists tell me that, I know I'm on a big story. And so it just promotes more interest on my part. But we as journalists need to take this whole suite of issues up and to publish and to do a really good job to explain it, because it's not getting better. And in fact, you know, the regulatory steps that are needed are not being taken. And so in order to change that, we need to build civic attention to it.
Okay. Carl, did you have a question for the team, or do you want me to keep going for the audience?
I just picking up on Keith's note there, with the farm bill, and these kind of other kind of, you know, we have these converging tipping points. So the UN is hosting the first water conference in 46 years next week in New York, right? So water is rising on the agenda. Eurasia Group named water one of the top 10 political risks of the year. And so where does something like the Farm Bill or the politics stand? Is that on the rise as far as response to this?
I think so. I think the Climate Smart program that the United States Department of Agriculture, Tom Vilsack, our Secretary of Agriculture, put in place with the help of Michigan's Senator Debbie Stabenow, who's the chairwoman of the Senate Agriculture Committee. I think that that's partially response. But again, all of these measures are voluntary. They're not required. And so farmers, as I've explained before, have erected an edifice of immunity for regulation. And until the public demands change, and it's going to take civic activism to do this, the regulatory system isn't going to respond. So how much worse does this get? Could get a lot worse. And when it gets worse, we'll deal with it. It's not apparently bad enough. You know,
we'll go more on the Farm Bill in a second, but Yuxiang, I mean, I wanted to ask you, and I know some as well, but what is China doing in terms of regulations around algae these days?
Yeah, thanks, Jennifer. I don't pretend I'm the expert in that, but I've been working there for 20-some years. Actually, that's where I'm coming from. Anyhow, so a lot of government-driven initiative been going on for putting money into reconstructed wetland. We know that's part of the issue, and Laura brought it up. It's a huge buffer zone, and taking nutrients, doing all kind of things, established biodiversity in the watershed ecosystem. I mean, the one incident I probably told you before, that's like a Lake Tai. It used to be just concrete banked for the entire lake. That's not even a small water body, but it's very shallow. Average depth by North American standards, nothing. It's like average depth 2 meters. That's like a shallow pool. But when you have no wetland whatsoever, that become a gigantic eutrophication, smelly water body. But lately, I used to travel there all the time, and I couldn't find any shoreline to do shoreline assessment with my student. Now you go in there, there are tons of reconstructed wetland going on there, and they are also learning how to make the wetland more functional rather than just looking good. So I think that's another very important thing. How do you make it ecologically functional? They don't have to look pretty. Wetland don't necessarily look pretty, and they are doing that. And then hopefully in the longer term, we don't see the result yet because that's going to take a long time. And but they are committing a lot of money into it. Whether that generate, but it is industry by itself, right? So they're building a lot of things going out there. So that's what I saw. That's how I can comment. Yeah.
So one other Jennifer, one other thing that China is doing is beginning to put wastewater treatment plants on its concentrated animal feeding operations. It's not a national program as far as I can determine, but it is occurring, and that's the same kind of technology and practices that we need to put on our concentrated animal feeding operations. the new bills that were passed, infrastructure and the Inflation Reduction Act, provide tens of billions of dollars to turn agricultural farms into energy producers. And a bunch of that money is going to CAFOs, right? The concentrated energy. So if we're ready to subsidize methane collection and processing as fuels, we certainly can require concentrated animal feeding operations to put on wastewater treatment facilities, but we don't.
Yeah, well, in China, I mean, should point out that, in 2014, China started their war on pollution, starting off with air pollution because of all the smog, but then a year or so later, they then turned their sights to increase on water pollution. So, I mean, better regulations. And what I've been excited to see is, you're right, Keith, that regulating CAFOs, getting the biogas, because they're big in researching on biogas, and they're following US's lead also on biogas for wastewater treatment plants as well, just regular ones. Also encouraging is that a little over a year ago, there was the Yangtze River Protection Law, the Wetland Protection Law, and I know you say, well, it's a law, it doesn't do anything, but they're Xi Jinping, his administration, it's really basing a lot of their legitimacy on getting some of this pollution and environmental problems solved. So it's encouraging, and it will still take time, but I do think that the big thing there was about the CAFOs that Keith also brought up. All right. One of the first questions we got was anonymous, but said, I'm going to ask you two questions. One was, what can your average citizen do to change the outcomes of harmful algae bloom in the Great Lakes region? And another person said, so that's like the individual. And then someone, Lin Win asks, what do you think about the solution of introducing direct payment policy that incentivizes individual and collective actions to promote implementation of environmental friendly agricultural practices? So you touched on that a little bit, Keith. So maybe start with you, and then
what can a citizen do? Show up at local government, show up at state government, show up at regulatory hearings. Michigan has had a process that's going on for more than a year to improve its CAFO permitting systems. So that's the first thing you do. I mean, you got to get involved. And in the United States, one person can make a big difference by getting involved. We've seen that time and time again across all issues. Now, what was the second piece about this?
Well, no, go back to that.
The other piece was, what can we do to have investment? That's what we are doing.
Okay.
In Michigan, it's $50 million a year on conservation initiatives on these practices, voluntary practices that are said to reduce nitrogen and phosphorus runoff. Well, they don't work. All right. So we need to change the techniques that we're applying to this, and we need to make them mandatory, not voluntary. And our lawmakers say, well, we have to protect food supply. We have to protect food. And I'm saying, okay, let's protect the food supply. But in the corn, for our corn production, 30 to 40% of our corn is being used for energy production, not for food production. You got plenty of give and take in the food. I'm just saying we can solve this. We have solved this by mandating controls on nitrogen and phosphorus runoff. We've done that. Let's apply it to agriculture. Agriculture is now big enough. It's a $1.1 trillion industry in the United States. It's now big enough, sophisticated enough, scientific enough. Farmers, I don't want to put farmers in a corner. Farmers are doing what they're allowed to do. Well, we got to shrink, what they're allowed to do, because the consequences of a minority of people, a minority of Americans, 1 or 2 million Americans, is now polluting the water for hundreds of millions of Americans. And that is not fair or right.
But there's also that I want to point out to folks, they should go look at Circle of Blue Stories, because there was a great one about community activists that brought lawsuit in Michigan that also helped push for better policy action in this space. There's someone, Alan Tien, says, we're expected to reach peak phosphorus by 2030, and production will likely drop off after this. How will this change algal bloom research, and I assume also action, in the Great Lakes watershed, particularly as climate change, warms the water? I don't know, but this sounds like a science question to me.
Well, I think that's a good question to be having. And my understanding is that that so what is peak phosphorus? We'll take a step back so everybody understands what we're talking about. So phosphorus currently, the way we get it is we mine it from various sources in the United States. There's big mines in Florida. There's also some mines in Canada, and those are like our big sources here. But when we get outside of the United States, there's other various sources. But I believe that the largest potential source for phosphorus in terms of mining it to be able to turn it into fertilizers in Morocco. And historically, there was some papers that came out that suggested we're going to run out of phosphorus. And if we run out of phosphorus, then that could be a huge issue because we don't take a lot of care at trying to, we don't use phosphorus sustainably. We'll just say it that way. But more recent studies have found that there's an awful lot more phosphorus in Morocco than we thought. So probably peak phosphorus isn't going to be as big of an issue. But once we start to run out of phosphorus in these other sources and we all rely on one country for a big resource like that, then that's where we start to have some potentially question, it makes things stressful, right? That leads to potentially some issues. So anyway, so how do we deal with peak phosphorus? Well, or running out of phosphorus, or how do we make phosphorus more sustainable in the first place? The thing is that we have to remember what we're doing, right? We're feeding all of this grain that we're growing to mostly to animals, right? And then those animals are then excreting phosphorus. And then that phosphorus gets put onto the ground and then gets washed away. Or we're eating the phosphorus, most likely, because then we eat the animals, right? And our phosphorus goes into a wastewater treatment plant. And what do we do with that? Well, if we're a good wastewater treatment plant, we trap that phosphorus and it gets landfilled. Okay. Or if not, it runs downstream and then it's out on the coast and it's basically unattainable. So what we need to do as a country or as basically a society is do a better job at trapping that phosphorus when it's concentrated and figuring out how to reuse it. Now, people hate that, right? They hate biosolids because that's putting human waste on things, but it's the future, that what we need to do is more sustainably use our phosphorus. So I would argue that instead of a wastewater treatment plant necessarily at a CAFO, what we need to do is figure out how to better support transporting that phosphorus and that manure farther. Because the real issue with livestock is that the manure is heavy and it's hard to transport, and that costs a lot of money, and farmers can't afford to do that and they don't make money off of it. So we need to make it more diffuse. And if we do that, if we spread it farther, then farmers don't need to get commercial fertilizer. We don't need the fertilizer that's being, basically mined out of the ground. And that is our sustainable phosphorus future.
Okay, thanks. I like taking a moment sometimes before the end. Do any of you speakers have a question for one of the other speakers? You need to ponder it a moment. I can jump in with questions. Yuxiang?
Well, okay, so I guess not necessarily questions, so just follow up on what Laura was saying here. Good. I guess there's evolution of our understanding of the issue here. So in the 60s, 70s, we used to think, phosphorus is a problem, and then we curved that on the detergent so that we thought we solved the problem. And then nitrogen become a problem, like Keith was saying. And then after nitrogen and phosphorus, we also think about climate change, temperature is the issue. And now, say, even without temperatures in some of the lakes, and at a lower temperature, lower nutrient loading, we're still getting this cyanobacteria blooming because of CO2. So it's a climate change, right? So of course, some of us don't believe in climate change and think that's just a cycle. But I think the issue is that when you look at the very, very ancient organisms as an indicator how our ecosystem is working, so indicating it is not necessarily balanced to our favor as a human being here, right? So I guess that understanding need to also evolve along with our how we see the world and what we can do here, right? Of course, I sound like a little bit pessimistic, like what they're saying, just arm racing between human and all this other
guerrilla warfare.
That's okay. That's just common.
Yeah.
Jennifer, I just wanted to also point out, look, in immunizing agriculture from responsibility and accountability of its wastes, which have turned into be the most important water pollution problem in the United States and generally in the world, but in the United States, by doing so, we changed the economics of the industry. Had agriculture been required to account and responsibly manage its waste, it wouldn't have developed the way it's developed. That's particularly true in the concentrated animal feeding operations. If dairies that have 10, 15,000 cows, some of them 20,000 cows, or hog operations that have even more animals than that, had to manage and treat and responsibly manage its waste, it would not have developed the way it is, because there's the cost there. And we have alleviated those operations, which are owned and managed by some of the biggest corporations in the world, from water treating its own waste, managing. We didn't do that for the steel industry, right? We haven't done that for any other industry. We've done it for this industry. And the country will reach a point. It will reach a point with either some sort of calamity around water contamination that affects many people, that could happen anywhere in the Great Lakes, or on the West Coast, or on the East Coast, Lake Champlain, right? When it comes to calamity, we're going to do that. But why do we need to go there? I mean, why do we need to go there in order to respond? Particularly this year, when we've just put tens of billions of dollars into agriculture. You know, we've just encouraged and incentivized agriculture to get even bigger.
And he leaves it at that. I mean, in some ways, we just got a question from Laura Schneider, just as you started talking, that was saying, can you give us 2 or 3 large-scale projects that can be built across the Great Lakes to fix the algae bloom? Is there such a solution? But I think you're saying, Keith, that it's more, we got to get the policies right. And that
we have the solutions. The solution is really easy. It's very easy. We need to curb, the amount of nutrients flowing into our groundwater or our surface water, period. That's what needs to happen. And we've erected a regulatory and legal edifice that prevents the government from doing so, actually protects the government, protects the agriculture sector from any sort of oversight and responsible management, right? That's what we've done. So in order to solve this, we need to change both of those factors.
But
I think, Laura, do you agree with that?
Laura, you might also have some thoughts too, because there's also some, I mean, even changing the laws today, the time it takes for the change to come. What are some things that you think could be happening? I mean,
well, I don't want us to conflate easy and simple. And I think Keith really means simple. Like, we know that we need to reduce nutrient input, so we reduce nutrient outputs, right? I don't think that that's an easy step to take, because of all of the policy involved, but then also the amount of time it takes to change a huge group of people. I know that regulation is something that is being considered, but the thing that we also need to remember is that there's over 14,000 farmers in the Maumee River watershed. So we're talking about regulating a lot of people. And if, I don't know what you guys know about things being regulated, maybe in Ohio, for instance, sometimes there's not a whole lot of oomph to that word. There's not a lot of follow-up. And so I'd like to, if that's a path that it needs to go down, then that's fine. But I think that there would have to be an awful lot more support for actually following up with that to see how that would actually work out. The issue that I have and the concern that I would have would be, I guess the biggest fix, if you were going to do one thing, we would find someone who would be willing to pay all the farmers in the watershed to not apply phosphorus for like maybe 5 years. Let's do it 5 years, see what happens. And then not pay them to not apply, but pay them, be like, yeah, if you were getting this yield and now you don't get this yield, then we pay for the difference in yield, right? So it's like, we can't lose that bet, right? You don't have to pay for your fertilizer, you don't have to do this. Do something more innovative, of course, obviously with manure, but in the Western Lake Erie Basin, 70% of the phosphorus inputs coming from commercial fertilizer. So that one step would take care of a lot of things. I think that would be the big solution, just to see how that would work and see if it would do it. I bet most farmers wouldn't actually take that bet. My bet would be that they wouldn't do that bet, but I do think that would be that's what we need to see and test and push the limits for. The flip side is also remembering why, aside from ethanol, which is 30 or 40% of the corn production, we have to remember why we're growing what we're growing, and that there's small changes in our culture could potentially lead to big changes wide scale. So there's all these wonderful things, like if across the US, all Americans did just 1 day a week meatless, 1 day, then there wouldn't be as much need to have all of these CAFOs, because we wouldn't be asking for as much manure, animal, food. That doesn't take care of anything that we export, obviously. And that would be an even bigger ask. But, taking those types of really small steps. I'm not saying everybody needs to be vegetarian, but we do definitely lose a lot of efficiency when we're starting to feed animals. So those are a couple of big things I would think could help.
I want to, Yuxiang, just for you to answer real quick, because I want to switch a little bit. I want to, highlight that, how you were talking about an actual kind of trying to catch these creative sign up the algae as it's starting to catch it and do this bioremediation. Is this something that China is actually has the government looked into your research? Do they want to expand this kind of tracking? I mean, it doesn't solve the problem long term, but it kind of buys time, correct?
Yeah, I mean, you are absolutely right, Jennifer. And but there's a disconnect here. That is, one is a eutrophication, one is an algal bloom, right? Because we see algal bloom, and then that get our attention, and then when you try to prevent that from happening, and then governments usually don't really see it as their effort being effective, right? Because they haven't seen the problem. You prevent that from happening, and then becoming a big issue here. So therefore, how do you allocate or convince government, regular citizens say we have an issue here, right? And then I think it's human nature. We sometimes, unfortunately, have to see the negative consequences before we can commit our resources to do something. I like what Keith was saying earlier, get involved and then informed. So I think if we as a citizen voice it, and then government hopefully hear it, and then they can justify certain measures, and say, even though when that didn't happen, that doesn't mean it didn't exist. That comes to a scientific understanding of this whole issue here. So that should just be from my very nerdy side of me saying, you got to know the issue, and then you can't pretend just sweep everything under the rabbit and like a carpet, just say it's not there. It's there, always there, right? So we just have to spend money and attention to deal with it. And just very quickly, even back then when we were working on it, in scientific side of it, and then we often get asked the question, why do we want to spend taxpayers' money to deal with someone else's problem, right, here in North America? And then I said, that's not just their problem, it's a global issue. And I said that for many years. And then I hate to say that, and now it's coming to us, right? So I think that, that's going to happen again. So it's just, we have to be proactive and try to deal with this ahead of time.
Yeah. Well, I thought it was cool too, that the work that you're doing in China and the Yangtze River Basin, that you've brought this kind of testing this also in Canada. Yeah. So that, this, like, again, it's a short-term fix. Your policy stuff, Keith, is going to take a little time. Yeah. But I think that I do find it intriguing, this preventative solution as well. Carl, do you have any comment you want to jump in finals? We're wrapping up here.
Yeah, absolutely.
Like, what's next with your algae stuff? You're going to keep swimming in the green? Yeah, that circle of blue?
Jennifer, it's always so great to work with the Wilson Center, and I think of the choke point China work and the India work, and how truly, the frontline reporting, getting on the ground, combining with the great scientific work that we're hearing about here today, and that's not enough, right? You have to convene like this, and I think we did 17 convenings across China around the choke point work. But there will be existential events. We're going to see harmful algae blooms. We're going to see, as Keith mentioned, we will probably have an event where a major city, whether in the US or Canada or China, has to shut down its water intake, like Toledo did in 2014. So, how do we seize these moments? And it does take persistence with policy, but it also takes persistence. Farmers don't want to be bad guys, and they know how to manage their land. They need some guidance, and also, Keith, some guardrails and the incentives, and to see the bright side on the other side and not the green side. So I'm always excited to bring groups together like this. It's just the start of a big story that's Great Lakes, national and global, and particularly at this nexus of water and food, which we're going to hear a lot more about, as you started, Jennifer. How does the world feed itself? And how do we manage that extra pressure, not only on water extraction, but on the runoff and the pollution that's the result? So that's what excites me, and I guess brings me some optimism and some hope here is driving toward the solutions.
Well, I want to thank all of you for speaking today. Keith, do you have like a quick 10-second thing you want to say, or are you done? You've pounded your fist on the table enough. All right.
I've said what I can say,
All right. Want to thank all you speakers here with even my gate crasher here, Carl, for coming and talking about this issue that doesn't always get a lot of play. We're going to keep our hands on the pulse of it, because again, I think that there's, we've seen in China that there's even examples of like working with farmers to protect wetlands, and there's a lot of innovation happening in China and the US on this, and so we want to also try to tell those stories. I want to thank everyone for tuning in today. We couldn't get to all your questions, but I did see some other examples. There was someone from University of Cincinnati that was giving some examples that they were doing there. So I'm glad we had the scientists out in force today. And if you're not part of the China Environment Forum mailing list, just go to our website, sign up. Next month, we're actually going to switch over a little bit to have a meeting on we've got plastic waste meeting coming up next month, but we're going to keep doing a lot on this ag and climate topic. So thank you very much, and everyone have a really great morning.